we're gonna cover example 5. In this example, we're taking two numbers whose product is 1. We're calling one of them x and the other one y, the corresponding value of x, y. So we can see here -2 times -0.5 is 1, but also -1 times -1 equals 1. For 0, we don't have such y value, so we will say that this function is not defined at that point, that particular point, but 1 times 1 equals 1. And if we group all those ordered pairs and we graph them, we get what is called the reciprocal function. If you guys remember, when the product of two numbers is equal 1, we call one number the reciprocal of the other. So there is sense in calling this the reciprocal function. So my general formula for the reciprocal function would be y equals 1 over x. And the graph here shows in green. I also colored two special lines. The one in black is a vertical line, and the one in purple, the horizontal one. In this case, the x-axis and the y-axis. Those are important features of this function because the graph in black, for which any point there has x coordinate 0, so the equation of the y-axis is x equals 0. This is called the vertical asymptote of the reciprocal function. And with that, we mean that this graph in green is getting closer and closer to that black line, but it never touches it after a certain point. So doesn't matter if you look up or you look down, that green graph is getting closer and closer to that line, but actually never reaches it. And we also see that for that particular value, x equals 0, as you could see on the table, that x value is never taken by the function. That means that you will not find a point in the green graph that has x coordinate 0, because the function is not defined there. So that means that you can divide 1 by any number but 0. You can never divide 1 by 0. Division by 0 is a non-existent concept in math. So we say that domain is all real numbers different from 0. So again, that means that you can divide 1 by any number except by 0. And then we have this horizontal line y equals 0, which in this case is the x-axis. Any point there has y coordinate 0. And this is called the horizontal asymptote. You can see it like a similar pattern, the green graph getting closer and closer to that line, but it doesn't touch it. And doesn't matter if you look right or left, it's the same pattern. And we can see that we can also say the range excludes the number 0, which means that there's no number that you can divide 1 by so that the answer is 0. So, in other words, 1 divided by any number is never ever going to be 0, provided that you're not trying 0, because we already said 0 cannot be on the denominator of this fraction. So we can be sure that 1 divided by any number is never going to be 0, but also we know that we cannot write 1 divided by 0 because that is not a number in the domain of the function. So let's look and see what happens when we do some translations. We have seen translations before, so we know that when we switch like the h by 1, let's say, so that would mean x minus 1. I want you guys to pay attention where those black and purple lines go after I switch this h to a value of 1, let's say. So now let's see, there you go. So when we switch that value to 1, then that vertical asymptote that before was 0 or the y-axis now is the line x equals 1. So that's the number right in the middle between 0 and 2. So that has to be with the vertical asymptote. So that means a translation 1 unit to the right will make that vertical line to move also 1 unit to the right. So from here, it's moving 1 to the right. So to find it, determine the asymptotes of this more general function, we will always look at the translation that we are doing. If it is a horizontal translation moving to the right, that'll switch, that'll change the vertical asymptote to a x equals 2, x equals 1, or maybe even x equals 3. If you're moving the if you're translating the graph to the left, that'll be like x plus 1. You will see also always the sign, the opposite sign here. So 1, right now we're graphing y equals 1 over x minus negative 1, which is x plus 1. And we know this is a translation to the left, opposite to the what the sign suggests it is. We can see plus, but it's not to the right, it's actually to the left. We covered that uh, in that before. So if we move that graph to the left, now my vertical asymptote will be x equals negative 2, right? So it's all all about like checking what is the number excluded from the domain, and that will be like the same equation for the vertical asymptote. In a similar way, we can see that when we played with the blue line here, but maybe I should have done this in different color, but now I'm not going to change it. So if we go like, let's say, a vertical translation of 1 unit, so maybe I'm going to switch it to different color, but let's see here, maybe black. So we can see that our horizontal asymptote has moved up um, the same direction that our graph moved, right? So now the horizontal asymptote is y equals 1. And if we move the graph down, then uh, like let's say that we are moving this point to be negative 1, so the horizontal asymptote also moves down. So for that, we're going to have to look at this value right here. And like for the value that goes with the x, we will not have to change the sign. So for us to remember will be like if we got x minus 3, then the horizontal, um, the vertical asymptote will be x equals 3. So that number that makes the denominator 0. And here, it'll take the same sign. So if it is plus 1, then that means that the horizontal asymptote will be y equals 1. If it is minus 2, it'll be y equals negative 2, and so on and so forth. So let's check and see if we can see what example 5 shows here. So with that explanation, I'm hoping that this will be much easier. So here we can see that there is a horizontal translation of 3 units to the right because there is a minus. So I always think backwards for horizontal translations. So that means our vertical asymptote went from x equals 0 to x equals 3. And the horizontal asymptote will be y equals 2 with the same sign that we see here. Also, that tells us domain is all real numbers except that number that makes denominator 0, and that number is 3. So we have to exclude number 3 from the domain of this function. So it'll be all real numbers but 3. And for the range, we'll have to exclude number 2, since the only way to have a value of 2 will be to have this fraction here equal to 0, but we know from the reciprocal function that 1 divided by any number is never going to be 0. So this could never be 0, so 2 plus this can never be 2. That means the range will be all real numbers but 2. So notice how the uh, asymptotes, the vertical asymptote and the horizontal asymptote, are also guides as to what is the number, or the numbers that we're excluding from domain and range. So in here we can see that because the graph has been shifted 3 units to the right, now the blue line has equation x equals 3, which is the number that makes denominator 0, and that's our new vertical asymptote. And our new horizontal asymptote will have to do with this plus 2, which is y equals 2. That's exactly what we said before. Hopefully now is much easier. So domain will be all real numbers. That's how you write it, uh, different from 3. And the range will be all real numbers different from 2. Um, so with that in mind, please try to answer this question. Play with the graph, trying to try to go over the explanation, and then give yourself some time and check the answer. Hopefully you got to the answers, to the correct answers. So x equals -2, which is the number that makes this denominator 0, is a vertical asymptote. Also, that is the number that you have to exclude from the domain. So it could be any real number but -2. And the range will be like this number -4 will be excluded from the range. And also that'll be your horizontal asymptote. All right, guys. So let's get some practice going on.